here. All right. So yeah, it's good enough. So hey guys, I'm Vagmi. So I run this. I work with a company called Tarka Labs and like Sudhakar. You can catch around like we guys. So we're all from Tarka Labs as well. So I've been working or writing Go code for the past 2 to 3 years. Although I knew Go before, but kind of been focused on writing Go for the past 3 years. So initially, I did not quite like Go. So I think I came across Go in like 2012 or 13, just when about Docker was getting popular, and I was like, okay, Docker is written in Go, and so I should probably check out Go, and I looked at Go. And I was also learning other languages like Haskell and things with fancier type systems or better type systems. And then I didn't quite like Go the way I saw it, right? And then I was like, okay, this doesn't have generics, this doesn't have like, abstract data types in them. What about all the immutability, right? It just didn't feel right actually. And but then I actually started maintaining a Go code base, and that's when it struck me, right? Go is not about these fancy type systems. Go is not about all these wonderful things, but it makes the code really maintainable, and that's when it really hit me that Go is extremely valuable for like really large code bases where there is a lot of engineers working on it. I think Go offers a lot of advantages actually, right? And after dealing with the concurrency patterns, after dealing with how easy Go code is to read and how easy it is to maintain, I think that's when I truly understood the values. Now this talk is basically a collection of small tips and tricks that I have kind of come across. They are in no particular order actually, so it's just a bunch of things. And as a craftsman, obviously you should be reading a lot more code, and do give more emphasis on reading code rather than writing code, and so on and so forth. So I've kind of picked up a few things on code bases that I've seen other places and things like that. So these are just a bunch of some examples. And if you, feel free to interrupt me at any point in time. We can have a discussion around the code, and we can go from there. Right. Go doesn't have enums, but then it has kind of, right? So let's look at this code. So one thing that I've seen in many code bases when they have to use enums is that they actually create an alias of the int type actually to whatever enum type you want. So we have here a character type, and the character type is basically an int, and I have 3 characters, right? Human, droid, starship, Star Wars fans, yeah. Right? And then I have another character struct that I have, which has a name and a type actually, right? And it has this keyword called iota, which basically sets it to 0, and any consts that are immediately defined after the block basically get incremented values, right? So now you have these, I have these characters. Now I can actually use these constants like so, just like how you would use enums. And if you run this, you see as expected. Now the cool part about it is you can have things like, you can say human is actually 0, because that's the int value. But if you pass human in this, right, this will give you a compile error. Okay. Why is that?
That's because it's inside. You'd have to keep it outside.
Oh yeah, sorry. Right. And so if you do this will be a compile error because it says can't use human type int as character type in the field, right? So it also gives certain amount of this thing to you where for a fact these are character types and they work that way. So it has some amount of type safety, and so even though Go doesn't have enums, it has enums, right? So
is there a plan to add enums? No, right?
No,
He's not.
language is
But
frozen.
you cannot list, say for example, enums usually, right? They are more powerful than this, right? You can get all the values. You can move through enums, but you cannot do all that here.
Yeah.
So
You don't need that.
dynamic.
You
need that.
You don't need
That's
that.
the problem.
Right. So, all right. Moving on. Right. There are receiver methods, right? If I run this code, what do you think the output should be? Anybody try to hazard a guess? Except Sudhakar, he knows about this. Anybody wants to give this a shot? It's a pretty simple code actually here. So I have a car struct, and I am basically setting up a stringer. I'm following the stringer interface so that I have a string method on that. So it's going to give make %s here %s, and then I give that. And I create a car, and I use fmt.println, which is supposed to call the string method on it and then write that. What should be the output?
It should be a make and new.
Make and here. Let's run this.
Right.
Yes.
Default print method.
Right. So this is the default print thing. So it doesn't actually call that method. Why is this method not called? The reason is that this is defined on the pointer, right? So you need to do this, then it works. Or if you still want to do this, you can do this, and this would still work. So if you define it on the base struct, then it will work whether the receiver is a pointer or in either case. So this is something that initially when you're starting with Go, it will trip you up a lot. So I wanted to call it out, and I've been bitten by this a couple of times. Okay.
So what is the recommendation?
There isn't one.
No, actually, I prefer this is better. I believe this is better because the moment you define something like this, right? What happens is every time you will copy the struct. Because in Go,
we're getting we'll look at one more slide and then we'll have this discussion, right? Because it's very pertinent to that. Yeah. Okay. So I have a car that's slightly old. So it's 2016. So I have a make new method which I changed my year to 28. Just upgrading, right? So I say my car and I say my car dot make new, and I'm trying to print it. What should be the output? Yes. Why? Exactly. Right. So it will call the make new method. So the method will get called in this case, but it's just not affect the thing because there is a copy of this car made, and it's on the copy that you're actually changing that. So when you call make new here, there's actually a brand new my car copy that is made and then sent to make new, and so it doesn't change this value. And if you have to change it, you have to do this, and then voila, the car gets upgraded, right? Yeah. Now to the discussion. What would be?
So maybe you go back to the previous slide, right? So I mean the copy by value as we see in, right? So what happens is for every method that you're calling, it will copy by value. Think of a struct as big enough.
I know it's a copy constructor kind of thing, like, but this is not like define. I'm value.
So, I mean,
kind of new to Go, so maybe.
Okay. So it's better to define like this, and always initialize your objects with unknown. So always have a pointer whenever you create a new structure object.
Yeah.
Instead of having a reference to the structure.
So that's a recommended pattern.
Yeah.
Yes. So recommendation by Sudhakar, by the way. So recommendation by people like Sudhakar.
Saying in one of the.
True. So this is what I feel about it. So when I agree that when you are expecting structs which have behaviors which are going to go through mutations and things like that, yes, I think this would be a good approach. But if you are primarily using structs as like a transfer mechanism, right? And so you just have something, just putting some data and then just transferring it over, and then whenever you want to transfer something else over, you're going to pass this along, right? If you're following functional sort of immutable patterns and things like that, then having just plain structs, I think it is okay. So I think the trick is not to think of them as a replacement for objects. I think that's where we get tripped up, right? When I come from a Java background, I come from Ruby background, whatever, right? So I kind of view structs as a replacement for objects in those things. Right? When you go through that approach, then this would trip you up. But once you adopt the Go idioms and you think of structs as structs, right? What they are, just a group of things. I think it starts making sense at some point. Or your brain gets damaged enough that you start making sense to you.
Does the compiler or does like in C++ world there's something called copy illusion and things like that, and same applies in Rust also, where the compiler knows that this is a temporary object, so I don't have to worry about copying it and things like that.
True.
Does the Golang?
Yes, there are. So it also, so in Golang, I'll look up the compiler flag, I don't know. So you can actually look at the analysis of what the compiler does, and it then decides, does this escape scope? And if it does escape scope, then it does allocation elsewhere and so on.
But those are just suggestions.
No, they are escape analysis that the compiler performs,
Yeah,
actually.
But those are not like, you cannot make a decision on that. It's just at a hint that compiler might do it. It thinks this.
Yes.
But what actually happens might actually be quite different.
True. Okay. I think the heading kind of gives away the problem. So okay, what would happen? Don't look at this. What do you think would happen when you run this piece of code? So here I have an animal which makes noise, and then I have a type dog struct, and I have a make noise. So I make dog implement make noise so that it satisfies the animal interface. So although if I go by Golang standards, I should have called it make noiser, actually, because they add ear to any of the methods that they do. And then, so I have this make noise method, and then I basically create a var animal, which is variable which is supposed to hold an object that conforms to the interface. And I also have a var d dog, actually, and then I say animal equals d. Okay, and then I say animal dot make noise. So I say animal dot make noise. So what should be the output for this?
Compilation? No, it won't be a compilation. Runtime execution.
Yes, it would say false.
I'm moving.
It's like false, actually. The reason is that compiler doesn't give you any protection whatsoever here if you decide to shoot yourself in the foot, because unlike if you do this and pass in this, there is, it would succeed actually, right? So in a sense, just saying var d dog, it actually has created a struct at that point in time, and so it's fine actually. But if it's a pointer to the struct, it is not pointing anywhere actually, and it can, this still compiles fine, but it's going to blow up at runtime, and it goes pretty badly. Yeah. So it's going to bomb at runtime. So you have to make sure that this doesn't happen on your receiver methods by being very, very clear about it. Or if you run govet will complain about it at the scope that's here. Sometimes not. So you just have to be careful about it. But to be safe, you have to do this. Right? And so it will say oops, and then you kind of guard it against it. Any
So
questions?
the basic thing is the method is still called, but the method is still called on this pointer.
Correct.
It's not called an null pointer.
Yes, it is called an endpoint pointer. Yeah, it is called an endpoint pointer. That's the beauty of it. The method is still called.
But
It
the
bombs here
field
and
is-
main.
When we access the field at that point, the value happens.
Exactly. The
Yeah.
method is called. Right? Because it
Some
satisfies the
instructions, right? The
interface.
instructions are not, they're not stored along with the object itself. It's not
It's not like
resolved,
Java, right? Where you say, okay, a method is associated with an object. Right? So this is a struct, and this is supposed to be a method which receives it, right? So and so.
The code is laid out during compilation itself. So there's just a control flow will go from that to that. That resolution is done ahead, kind of. So it will jump into there'll be if you look at the stack trace, then it will be like, that function will be called with arguments as this value.
Exactly.
Right? It's like
It should be
point and
done.
self or something. The first argument is the object's address or something like that, right? So it will just pass 0 as the first value of the function. And when you call something, when you reference or dereference that object or that address location, then you get that.
Yeah. Then it just bombs at that point in
So
time.
in C++,
Same thing.
Same thing. Yeah.
Same thing. That's this no. This is basically everything is laid out by the compiler ahead of time. It knows the control flow when it compiles. So it knows which function to call. All that is resolved except for like the
What will be the first parameter?
polymorphism or there will be a v table that also is kind of sorted out at that point. But still, the object's address itself not for the statically. For other cases. At the compile time, we know which function needs to be
Which is
called.
kind of surprising that there is no compiler error. It even gets to the method and then bombs at that point.
But it doesn't know ahead of time that this is null,
Correct.
right?
Correct.
That is something that the first argument value is null is not known at compile
True,
time.
true. So when you're having interfaces and you make interfaces satisfy on pointer receivers, you have to be very careful, actually. Moral of the story.
Maybe that's why it's better not to have receivers on the pointers. Right.
Now Sudhakar is questioning.
He's what recommendation.
Should we write go?
No, I'm already questioning that.
Alright.
Okay, one
So,
more. What if you had like in that method, if
Yeah.
you had made this, I mean, declared that method not on pointer and then the actual object itself, what
Yes.
would have happened?
So, I mean, you can't call this, so you'll have to dereference this. So at this point, this dereferencing here would cause a problem.
Okay.
Yeah. But would it be compiling or runtime?
It'll be runtime. It'll still be runtime because.
But the line will be here, it won't go to the function at all.
Yeah. But yeah, it'll actually bomb it here. It'll bomb here. So is it compiled 20? I mean, you don't know it here, but yeah, this is you are trying to dereference a null pointer here. So where at the point of dereferencing, it will fail. Essentially, that was the same problem. It's just that where you're trying to dereference. All right, now let's. So this is another thing. I mean, I actually have been dealing with Kubernetes a bit these days, and I've been trying to fight with the cloud provider there, trying to look at their logs on Kubelet, controller manager, and things like that. So one of the things that I found really nice was they had the file name and the line number whenever they wrote logs. Actually, I found that was really nice actually for them to do, and I wanted to do the same thing. So you can actually use, there are existing logging libraries like Zap and things like that which do that, but I wanted to show you how easy it is. You don't necessarily have to do this. So I mean, use a third-party library. So this actually, whenever I'm calling a log, instead of a log, I'm calling a decorate method here on my message, wherever I'm going to log. And this decorate message basically, there's this package in Golang called runtime, actually, which lets you, access runtime information and all that. So there I can basically, runtime.caller will get me a frame. We'll have the entire call stack. So I'm basically going to say, I want to skip one call stack, actually, and look at the next one, because the current call stack will be the decorate method itself. So I would want to skip one and call that. So, I mean, first one gives me a pointer to a stack trace, so I don't care about it, so I throw it away. And then I look at path line, and you can have OK, but then we can also, I mean, the idea is that if you are too deep, then this OK would be false, because there aren't enough things in the stack. But I know for a fact this will be there. And so I then look at the file path, I split it, then I look for the, file colon line, and then I give the message. So the output looks a bit like this. So there's no quiz here, it's just that it's nice to have this output coming here when you have these logs. So it's easy for you to know where these logs are coming from, right? So you don't have to get up for that value and things like that. You can just jump to them.
It's called compile 14, now it's fine.
Yeah, so all of these are called like, this is the play thing. So play actually, for every time you run this again, it will be compile 15 actually.
Creates another file.
Okay, so cool. And similarly with errors, right? So error is an interface in Golang, right? So you just have to have an error method which returns a string. So it would be nice if you have, like for example, here I have this error which is called oops, and I say hello, which returns an error. I look for the error, and if it's not nil, I panic on this error, right? So let's try to run this. So now it says panic oops is caused by, and it gives us call stack actually here. So it will be nice to have this information in the call stack whenever you have these errors, right? Although I'll have to qualify this. In Golang, you treat errors as values, right? They are not exception workflows. So that is the reason why you don't want to attach stack traces all the time, actually. But say for example, when you're trying to open a file, right? The file doesn't exist, right? It's one of the failure modes, right? So you need to basically enumerate all those failure modes and say, okay, attach this. I mean, this is the failure mode this works with, and so on and so forth. And when you are not able to do that, and you are basically bubbling up errors all the way from like a underlying program, right? And it's very common that we see in Go patterns that, okay, you call something that has that expects an error, but that error is returned like, some 3 or 4 functions that are beneath, and it's like really crazy where this error is coming from and what I should be doing, right? What is the stack about it, and so on and so forth. So it'll be nice to have this stack. And again, there are many open source libraries which actually implement that, but it's kind of fairly easy to implement. So I mean, like few lines of code you can do that. So I have a better error struct actually that I want, and that implements the error method which satisfies the error interface actually. And once I have that, then again, runtime caller is awesome actually. So I basically try to find out where that method comes from, and I basically have like a 20 size stack that I create. I assume that I'm going to get about 20 values, and I basically do a runtime.callers of all these things. So even if your stack is only 5 frames big or 6 frames big, it is basically going to write that and going to give me back how many frames it has written actually. And then I use that to get to all the caller frames actually, and I have this from caller frames method here. So where I declare a stack frame, where I basically say, okay, this has a file, line, and function. I basically get the file, line, and function from each one of the stack frames, and I populate this. I mean, this is just drudgery code where I basically walk through each one of those and then populate those values. So what then it helps me do is that I now am able to set the stack trace here actually. So that way my errors actually have a context of where it happened, and it would help me debug a little bit better when I'm logging them out actually.
Can you show me the output of the before one?
Yeah.
Is it showing for every stack or for every stack line? It is showing the.
It's showing which file
line number. Okay.
and the line number.
Okay.
So I clearly know, okay, this is the flow that was taken by the people. So it really helps when you are debugging, or when you have especially new people looking at log files. So I saw some of this code in Jaeger actually. So
Makes sense.
okay.
Stack trace has a string of implementation.
Yeah. So there is also, I mean, if you're just debugging locally, you can also say this is runtime.debug package where you can say debug.dump stack trace, which then writes it to stdr, and it doesn't follow your logging mechanism. Here you can write it to your logs and work with that. Okay. I mean, I think the previous talk basically did a much better job, but this is just one slide. So reflect.dpickle is nice. You should use it. I mean, sometimes when you have deeply nested structures and you want to do that, you want to do this. Now this is a fairly simple case, but we'll slowly start building on it. So here we have two structs. We have a struct which has name value, and again I have a status struct that's here. And I basically create two pointers, and I say reflect.str equals strb, and then it says here. So I'm just going to work on this a little bit, and if I say str equals, so now it's not going to print a because I'm trying to compare two pointers, and so they're not equal. But I can dereference those, and Golang's double equal to is actually pretty good, where it will now print a if they are clear values. So you don't need reflect.dp equals at this point in time if they are pure values. But say you have a struct which is like this, which is very common, right? You deal with Kubernetes code bases and things like that. I mean, they even have pointers to int32s and things like that, which is absolutely crazy, and you can't do equality there. So there, so let me change the code a bit here, right? So now this will not print a because even if you dereference to those pointers, because the underlying pointer values are actually different, right? So the status pointers values are different, and the only way it would work is to actually use reflect.dp equal at that point. So, and that's the reason why reflect.dp equal exists, where you can do this, and reflect.dp equal works for many types, not just this arbitrary structs, but also for maps, interfaces, things like that, where it actually finds out if it's a pointer, it dereferences them, gets the actual values, compares those values, and things like that. Right.
Very rookie question. So does it do nil check when it dereferences?
Which one?
Dereferences? The D?
Dereferencing. So, for example, now, so you're saying if
Let's
I
say
have
you
status
status.
nil, like this one, is it?
Yeah.
Status is basically nil.
Just one.
Yeah, just one. Yeah.
No, I don't.
Just one.
Yeah, this would work. Yeah, obviously. This one.
Okay. So it doesn't dereference and all that.
Yeah,
I mean, it handles the
it handles all
Safe.
those.
Yeah. Okay.
It's safe. It's
Yep.
safe. Right. Okay. Now,
Checks out.
take a deep breath. Okay. One more thing. So, is this okay? Are we going in a good pace?
Yeah.
Yeah.
Is it helpful? Okay. Right. So, struct tags. I mean, you would have seen this in like every time you have to write structs which need to go down to JSON, or you write your mapping, you find these struct tags, right? And if you ever have to write those, it's actually surprisingly easy to actually do that. And the way you do it is, so I have a person and I have my own maps to tag. Any hitchhikers guide to the galaxy fans here? Okay. So yeah, so Arthur Dent is one of the protagonists of Hitchhiker's Guide to the Galaxy, which by case, I mean like, which is awesome by the way.
36?
Huh? I'm sorry?
Is his age 36 or what?
Yeah,
I think
around
that's
that. I like to portray myself younger, so I speak like this. So anyway, so I have Arthur Dent, which is who's like this, and then I can reflect on the struct type. So you can do a reflect.type of and reflect.value of, and then it gives you like the value interface for this and the type interface for this. So I'm doing both. I'm doing a type of and value of, and I try to basically look at all the fields that are there in the struct. So I say num fields, it will give me the number of fields that are there. So I basically do a simple for loop, and then I do struct type.field of I, which will give me the field information, that is each one of the fields that are there in the struct. And then I try to do a tag.lookup on that, and then it gives me the tag name. And if it is okay, because if you could have fields that don't have the tag on them, which you don't have to worry about, and then you basically get this value. So
what's reflect.value? Sorry.
so reflect.value of, so it gives you the value so that you can do a value.field by name and then get the value.
So if you want to access the value of that struct, you can use only the value of.
Value of. So this gives, the struct type gives meta information about the struct. Value actually turns it into, I mean, it gives you any struct. So that means that it accepts an empty interface actually, and then it lets you look up a field and say this is the value of the field and the type of the field and things like that. And here I'm cheating because I have used a %b here. So whatever is the underlying field type, it's going to call the stringer interface and write it there. Actually, so cool. And so now you say full name map from f name to the value of Arthur Dent, and the age map to age with value of 36, things like that. So that way you basically can access pretty much everything about the struct with reflect package.
But there's no other way to access that string, right? Without reflect package, say in the struct.
Yeah, you have to use the reflect package for consuming, but you just have to do it once, right? In the sense you can say you can basically cache the struct type field actually, and say every time you encounter another struct of this type, you can basically do that.
What are applications for this, like serialization, deserialization?
Serialization, deserialization, anything to deal with the database mapping.
I see. So if we end up writing a library, like a very simple map.
Where we get the,
Right. And yeah, I mean, to talk about Go and not talk about concurrency is like crazy. So we'll talk about a few concurrency patterns in Go. So in a sense that, I mean, of course, I also come from other languages like Clojure and Java futures and things like that. And so I wanted to basically say, okay, how others can also be achieved. Right? I see futures are like kind of the thing which is often done in this thing. So the idea is that, okay, now we have a method called fetch, which then returns a response channel. Response channel has a body and an error, actually. So I'm actually doing HTTP get here, and then I wait for the response to happen. And once the response is available, then I actually write it to the REST channel, actually, right? And the pattern in pretty much all of these things is that you create a channel, you immediately return a channel, and then you have the management within a Go function. So within a Go routine, actually. So this is responsible for closing or doing any work with the channel, actually. So let's see how it's used. I'm actually fetching, so I hope the Wi-Fi is good here. So I'm actually going to fetch that. I'm going to get tarkalabs.com, but if you see here, it automatically says, I mean, once the fetch call is there, okay, I'm doing other things, and I'm then going to wait on the future. I mean, right, so I'm going to dereference it, and or I'm going to wait on the channel, and so it's going to block execution at that point in time. Then it's going to get the body, and after that, it's just parsing, and then showing the result, actually. So that's that. Any questions? Any observations here? You're good.
Can you go back to the
Yeah.
Okay.
There has to be a catch somewhere. So this returns a channel, actually. So.
output in each?
Yeah, we just declare it, wait for the output, and then and basically that's blocking to wait for the
Yes.
answer.
So this is one way I have seen in many code bases how channels are used. Basically, they are used as futures. Okay, and then you also have like Python style generator functions, right? So in a sense, okay, this is a Fibonacci generator, but instead of giving the numbers as such, it actually has a gives you back a channel, which then you can pick out each interface. I mean, technically speaking, it has to be an output only channel because I have to do this. And here, I mean, again, as you see the pattern, right? So you have I mean, most of these code bases work like this. So they create a channel. This method is responsible for setting up closing and things like that. So you create a channel, you return the channel immediately. And then you also call GoRoutine in the meanwhile, which is responsible for closing the channel. Here. So here, it basically generates those Fibonacci sequences and it keeps writing those to the channel. And once it's done, it's closing the channel. In the main function, I can now use this as a generator, right? So I can just do a range of the channel, and it would basically keep yielding values from the channel until it closes, actually.
So
I hope
how much data can a channel hold?
Here, only one value at a time.
So
So
until
as
the value is received, it will just wait.
It will just wait. You can't even write to the channel until the values. Or you can use a buffer channel where, I mean, I'll show you, I think I have one example of a buffer channel where you can put multiple things in buffer and then it will hold till that, and unless you're pulling off one value from it, the consumer cannot write to it directly. Cool. So far so good? Okay. Map reduce patterns, right? So this is a little more involved example, so I'll take my time to do this. So I'm going to write a function which basically is going to do a whole bunch of jobs, and we want to like send it off to multiple workers and then collect all the outputs, summarize it, and then show it, right? So that essentially the kind of pattern that you have, like a fan in, fan out sort of fan out, fan in sort of response. So I'm going to have a generator function. So all this does is that it actually gives you a channel of durations. Okay, so it's a channel of multiple time durations. And to do this, right now I'm just generating 10 durations that that could be between 1 to 10 seconds, or rather 1 to 10 seconds actually, right? It is going to write this to the duration out here. And I have a buffer channel here, mostly because I wanted to show that you could buffer on channels, right? So you could put one value in that, and it would hold one other value in buffer actually. So, and again, it's the same pattern. So you start a channel, you return the channel, and there is a method in between which is responsible for closing the channel, right? And writing to the channel and closing the channel. Okay. So any doubts with the generator?
And all it adds is numbers into the.
It just creates. Essentially, it creates new durations actually. So which is between 1 to 10 seconds. Right.
There's no sleep, right?
There is no sleep. It just writes to that channel. Okay. And then I have a worker. So worker is supposed to take a duration and return a int actually. So that's my worker function, right? So, but it's going to check a channel of duration and return a channel of int because we are dealing with streams, right? So it's going to take a stream of durations and return a stream of this thing for anybody in the RX world, right? So we're doing stream processing. So again here, the same patterns: create a channel, return a channel, and close a channel in a GoFunk. Okay. So I basically do a range of durations, and then I do a time.after on this thing, so that it gives me back a channel that will return the current time or the time when it's done, right? So I say I'm going to sleep for or wait for so many seconds on the duration, block on the channel, and then convert it in an integer and write it to the out channel.
Where is sleep there? Do you have access to sleep?
Yeah, no, time.after
Channel
gives me a
after
channel that lets me, that will only return after that thing has elapsed. So it essentially works. I could also call time.sleep, but then since I'm talking about concurrency, I thought
But if you have time.sleep, you can't block on it, right? You wouldn't be able to.
No, time.sleep blocks on the current thing. Essentially, time.sleep does this.
Achieve the same effect.
It achieves the same effect, but then it's not that impressive.
Confused the audience.
Confused audience.
So now there's a channel for sleep.
Yeah, right. So we have seen the generator, we have seen the worker which does this. Okay. Now let's talk about the reducer. right? So essentially what it's going to do is it's going to get value from multiple channels and then turn it into one channel actually. So this is going to do a fan in of these operations actually. So I make a channel of int here. Again, the same thing, I return the channel, and this is responsible for closing the channel. The Go routine inside is responsible for closing the channel. So whenever you write these patterns, you just write that first. Okay. And then here, ignore the timer for now, it's a cheat actually. So the thing is that now this worker only deals with two work. I mean, this reducer assumes that there are two channels, right, that you have to work with. Now I'm going to do a select statement. Now select is I mean basically like it selects values from multiple channels that are there. So I'm basically going to select from chan 1 and chan 2. So when you are doing a select on this and you are receiving from a channel, and if you put it in an infinite loop, now select will read from closed channels, okay, and it will return the default value of whatever the channel is supposed to have, because channel is not supposed to have pointers, it's supposed to have values. So chan of int, the default value of int is 0. So if I select on this and I keep reading from a channel and the channel is closed, it's going to give me back zeros. Okay.
Please tell me
So,
it's a bug. Please tell me it's a bug. And
it's not a bug actually. So you are supposed to check for OK, because it's also going to, it's actually going to give you two values, and the OK will be false if the channel is closed.
It's Golang.
Right? So yeah, exactly. I mean, you
used to those values.
yeah.
I mean, if they fix that bug, we don't need this pattern, right?
No, it's not a bug. It's not a bug. I'll tell you why it's not a bug.
Okay.
So, writing to a closed channel will panic, okay? Because
Right.
only a person who owns the channel is supposed to write to it,
Right.
okay? Reading from a closed channel is not this thing, right? They give you a mechanism to check on this. So, if you're sure the channel is going to be open, right, then it's not a problem.
Right,
but if you don't
select
know,
implementation can check whether the channel is closed or not and not read it, right?
no, select doesn't have, so select is not completely aware of all the semantics in this channel, right? So what select does is that, does this return a value? If it returns a value, I do this.
Okay, so case is special here, right? Because you are selecting on a channel, you don't need to do the typecasting in the sense. Right? When you're reading from the channel, you know it's an integer type and you will type.
Yes.
So case has some special
No, case
clause.
doesn't. No, case doesn't have that. I mean, this could return a completely different value. This could return a completely different value.
Correct, but you have said your DUR1, you clearly know inside the code that what type it is.
That is only because chan 1 gives me a chan int.
So still case is not special, is what
Yeah,
you're saying,
case is
even
not
for
special.
channel.
Come
Yeah.
out of display things of that kind.
Yeah. Right. So it's not. So it's in a sense. So that's there. So if I get a value and if the channel is not closed, I write it to C. Yeah. Okay. Now the thing is that I don't know when these things are going to get permanently closed, right? And there's no way for me to break out of this because I'm in an infinite loop here. So what I do is that I know, because of the nature of the problem, that if I don't receive something for 10 seconds, then obviously both these channels are dead, are closed. Just bear with me for a minute. Okay, there's a better implementation of it, but this is a naive implementation where you have to deal with it at some point in time, because you, I mean, you may be doing a for select in an infinite loop, and timeout is often the way, and context is there to help you. Essentially, that's what context has, and like deadlines and dates and things like that. But we'll not go there. I mean, we'll talk about a naive implementation first. Okay. So I mean, because of the nature of the problem, I know for a fact you could have a timer, and and I could wait on the timer's channel, and even for 10 seconds, if I haven't received anything, I can break. But I have to do break, because if I just do a break, it will only break out the select case and it will go back to the for. So I have to break to the outer loop, and I break here, actually, and I come out of for and I close the channel. Fair enough?
Nice.
With me so far?
Yeah.
Okay. Okay, now I have a controller. Okay. Now the controller basically takes the values from the generator, has two workers actually, and it's the same worker function. I'm basically giving ID 1 and ID 2 so that in logging I know which one is basically writing the data. And then I get a reduced channel where I do a reduce on this. Now I can do a range on these values, which are basically, because it's going to give me a channel of ints, and then I'm going to say this actually, and this is going to call the controller. I mean, ignore the dynamic controller, which is usually a kind of a better way. We'll get to this thing, and we'll try to run this and see what happens. So generator writes something, workers pick it up, generator again goes to sleep, then the reduced value is called for this, and so on. It works, essentially. And finally, it's going to wait for 10 seconds, and then say, I'm done in so many seconds. I think it's waiting for the final 10 seconds. So I think it's no, it's done. It's waiting for the final 10 seconds.
So you're adding
Yeah,
10
it says done. Essentially, and the total runtime of the program was like 40 seconds. So, and so it should have been 39 seconds. I'm sorry, 29 seconds, if not for the timeout. Essentially, I mean more or less. Right. Okay. Now, I mean, I decide to speed things a bit more, and now I want a dynamic thing. Right. This static reducer is not working for me. So I don't want to do this for select this timer thing and all that. I want a dynamic list of channels. Give me a slice of channels, and I will deal with this. Actually, right? Then okay, what do you do then? So so there's this thing called the weight group. Actually, so especially when you have these multiple channels, what you can do is you can create a weight group, and you say this is the length of the weight group, and as and when each worker is done, we will basically say I'm done, right? Yeah,
Is it
decrement.
join? Is it like join?
Is it? Yeah, it's a bit like John. Yeah, it's not exactly join. You're just telling that this particular weight group is done.
You just wait for it to go reduce to
Yeah.
like a then.
Yep.
So I-
in the sense that in the
It's
sense
a
you join the thread, right?
Yeah, so
Yeah,
that's what I'm
yeah,
saying.
the same
It's
thing
not.
as Java.
Yes. The reason why I'm saying yeah, you could say that. You could say that. The semantics are slightly different, but I mean, essentially that's what it achieves. Actually. So you start a weight group, and then you add basically say, okay, I want how many ever number of channels that I give to complete. Okay, if you pass in 5 channels, I want 5. It's basically the things that I want done. Right? It doesn't care about what is done actually. It just waits for that. So now I have multiple Go routines in here. One is that I basically do a range of channels actually. So if I give 5 channels, I'm going to range over all of them, and I'm going to create 5 different Go routines actually. Okay, and I have already created one channel here, and I return the out channel, which is this, and all it does is that this again ranges on each one of the channel that it gets here, and writes that int here. Fair enough? With me so far? No? So I get, so this is from each one is from the worker, okay? So you get a channel of int back. So each worker is basically going to give you ints after it's wait for some time, done some work, and it's like giving the result, right?
Array of out channels.
Array of out channels actually. Now from array, each out channel I'm basically doing that, and I'm writing it to my reduced channel. Okay, so I'm fanning in the operations, and once this channel is done, like one particular thing is done, I basically say, I signal the weight group saying that one of them is done. Right?
In a group of channels.
Yeah,
One
in a
of
group
the
of channels,
channels.
one of them is done.
He's not actually adding channels, there's a counting 5.
Yeah.
So how many times he calls, the moment he calls 5 times done, it's done.
It's
So
done, essentially.
Yeah.
So, and that's when I need to close the outer channel. I need to close the outer channel when all of these guys are done. Essentially, that's what, because I'm using range on the other end, right? So, I need to close the channel there. So, now what I do is, I then actually have another Go routine, actually, where this waits on the wait group. It just blocks until everybody else says I'm done. And when everybody else is done, I close the outer channel. Simple, right? So that's about it. Now, what this does is the same thing. So earlier we had the controller, we saw that. Now with dynamic controller, so again here dynamic controller is basically the same thing. Instead of calling 2 workers, earlier we created worker 1, worker 2, and we were doing this. Instead of doing worker 1, worker 2, I'm basically getting a count of workers. I'm creating as many workers over here and getting the channels, and I'm doing a reduced dynamic on it. And again, everything else is the same. So I run this. So it starts with 5 workers, and I mean, since more work is happening in parallel, it will be faster.
So many channels.
So implemented mini Spark here.
sort of. These are like patterns that I've seen in other code bases also following whenever they were like
Where did
scraping
you
and
see
things like
such
that.
code?
Huh?
Hadoop.
No. So this code, I actually saw it in Scraper actually.
It's, I mean, in
Some
Golang,
Scraper, I forgot the name. Yeah.
Really?
The scraping framework, which I.
Oh yeah, watch out.
Yeah.
Like.
We should include such.
Yeah, it was done, and this got done significantly earlier than the earlier one because it took me.
It still felt like we are waiting for a long time.
No, I didn't scroll down below.
Maybe you should try 2 channels and see the time. Then you.
Yeah, I think it'll be
it's
this. Yeah, we can actually.
You'll not wait for 10 seconds, right? So.
Yeah.
No, it still would be the same.
It won't be. I mean, yeah. In a sense, these are random channel numbers, so you cannot canonically determine whether this was faster or. I mean, but from semantic perspective, you know for a fact that you can scale up and scale down based on what you need actually here. Anyway, so that brings me. I mean, obviously there are several other things that you can talk about Golang. You can pretty much talk the entire day about all the nitty-gritties on this. But I guess thanks for your time, and this is all I prepared for. And if you have any questions, he really wants to wait for it. Any questions? Anything that you want to ask us about? And the reason why we are facing a lot with Golang is because he's wearing the t-shirt with Cluster.io. We are actually building a product which is built on top of Kubernetes, and we are using Go quite extensively there. Actually, so. Okay. All right. Thanks, guys. Thanks for your time. So. You can always find me, and I will also put all these slides are on GitHub as well.